Probability of compound events. For the probability of compound events, first, decide if the two events are independent or dependent. When the outcome of one event does not affect the outcome of another event, the two events are independent. When the events are smaller in size, a sample space or tree diagram can be drawn to show all of the possible events. A sample space is a list of all possible outcomes that can occur. The sample space for rolling 2 dice is given below. A tree diagram is a visual way of showing all possible outcomes of 2 or more events. The sample space for flipping a coin twice is shown as a tree diagram below. 2 dice are being rolled. Find the probability of rolling snake eyes. That means 2 ones. Begin by writing out the sample space for rolling 2 dice. As you can see, there are 36 possible outcomes. Next, determine how many outcomes fulfill the desired event. Here, only one outcome fulfills the requirement of the desired event, rolling snake eyes, 2 ones. Therefore, the probability of rolling snake eyes equals the desired number of outcomes divided by the total number of outcomes, 1 over 36. A coin is flipped 2 times. Find the probability of the coin showing heads 2 times, so both of the times. Begin by writing out the sample space for flipping a coin 2 times. So the first flip, we're going to get either heads or tails. And then the second flip, if we got heads the first time, we might get heads the second time, or we'll get tails the second time. If we flipped tails the first time, we might get heads the second time, or tails the second time. Find the path that shows the heads outcome 2 times. Here it is, the top path. Therefore, out of the 4 possible outcomes, only one of them fulfills the desired outcome. Therefore, the probability of coin showing head 2 times is 1 out of 4. If we look at the probabilities found using our sample spaces, can we determine a general formula or shortcut that can lead us to the same solution? Discuss in your groups. We can multiply the probability of both events together. So the probability of A and B happening is the probability of A times the probability of B. So when you roll a dice, 1 dice, there's 6 possible options. So rolling a 1 would be 1 out of 6 chance. For the second dice, it's also a 1 out of 6 chance. Therefore, the total probability of rolling snake eyes is 1 out of 36. When you flip a coin, the chance of getting heads is 1 out of 2 for both of the coins. Multiply it together and you get 1/4. This shows the cards included in a standard 52 card deck. We're going to use this for reference when determining the probabilities related to drawing specific cards or groups of cards. Select a card from a deck of cards, then replace it in the deck, shuffle the deck, and select a second card. What is the probability that you will pick a 6 and then a king? So we're going to multiply the probability of picking a 6 times the probability of picking a king. As you can see here, there's 4 6s in a deck of 52 cards. So the odds of picking a 6 are 4 out of 52. Then a king. So because we replaced the card back, there's still 52 cards in the deck. So this denominator is still 52. And there are 4 possible kings. Therefore, we're going to have 4 over 52 times 4 over 52, giving us a probability of 1 over 169. When the outcome of one event affects the outcome of another event, the 2 events are dependent. And you're going to use the formula, the probability of A times the probability of B given A. Let's see this in action. Select a card from a deck of cards. Do not replace it in the deck. Do not replace. Then shuffle the deck and select a second card. What is the probability that you will pick a 6 and then a king? As you can see, there's 1 less card in the deck when you go to choose the second card, so the probability will be different. All right, so the probability of picking a 6 and then a king is the probability of picking a 6, which is still 4 out of 52. Then the probability of picking a king, now that we're missing a 6 from the deck, is 4 over 51. The denominator went down by 1. Why? After you took out the 6 initially, the total number of cards is reduced by 1. But it wasn't a king initially, so if you had chosen a king and then another king, the numerator would also go down by 1, right? Because there would be one less king to choose from. But in this case, we're removing a 6, which did not affect the number of kings in the deck, but it did affect the total number of cards. Try to name some other independent and dependent events. Here are some independent events: flipping a coin multiple times, flipping a coin and rolling a die, spinning a spinner multiple times, drawing multiple cards from a deck and returning them into the deck after you draw them. Here are some dependent events: drawing multiple cards from a deck and not putting them back into the deck before picking the next cards. Picking 2 marbles from a bag without putting either marble back in before you take more marbles out. Or choosing 2 different students from a class to participate in an event, for example.